the system. Already we have seen the information system. We want now to see the cycle. We see the system development life cycle, and this one, when you talk about life cycle, it means there is a process that is there. There are stages actually. We can call them the life cycle or the stages, which there are goals for you to develop a system. The first one, we have the problem, recognition, and the definition. We are going to see what it is. We have the information gathering. We have requirement specification. We have the system design, system construction or the coding, testing and implementation, and system review and maintenance. And here you find that you cannot move to the other stage when one has failed. So for you to go to the second stage, the first one must be successful. If it happens that the first one fails, then you think of another system. That one cannot work. Or for example, the first two works and then the third failed. Then it means you have to rectify the third one before you move to the fourth stage. I start with the first one, the problem, recognition and definition. Those terms are self-explanatory. You can be able to tell what is to recognize, to identify actually. Definition, you want to identify where is the problem coming from. How is this old system? What are the challenges of this old system? So you are recognizing the problem that is there. For you to solve that problem, it means you have to tell which problem it is. We have the information gathering. When you talk about information gathering, this is where you move to the field. You go out there, you gather information. So after the problem recognition, you have defined the problem. You already know which challenges are in the old system. Now you move out to get information or to study. So it's like a fact finding. In other words, you can call it the fact finding. Fact finding. You want to come up with facts. So the system analyst, there is somebody called the system analyst, which will be covered later in form 4, the computer careers. The system analyst is the person who is developing the system together with the programmer, because they will be coding somewhere. So system analyst now proceeds to identify the techniques that will help the management to gather enough information related to the system. So the version of gathering of information require you implement a computer system, and we have the objectives of fact finding. We have the objectives, why, or the main objectives of fact finding. One, to find out what the present system is attempting to do and the scope of the objectives. How is the old system? How is it working? So for you to compare or for you to come up with a new system, you require to revisit the old system. Another objective of fact finding is to collect information about the input of the present system. To collect information and the inputs. For you to get the information or to get the output, you have to know what kind of input that you want to keep in the computer. You also have to find out volume of the input. What the size? What the size? This is where you even know what type of computer you will use because of the size or the memory. We also have 5 files maintained by the present system. How is the old system putting the files? So this one will also be defined. You also have to find the equipment that are used. Equipment. For example, you want to use a barcode reader or a scanner. Which type of scanner will I require for me to input data? So this is where you will know the equipment. What type of computer do I require? What is the size? And so on and so forth. And you also have to ascertain the cost in the information gathered. Now with the new system, cost. How much am I required? So those are the main objectives of the fact finding. And this one must be put down in writing. The fact finding, you have to put it in writing. So you come up with document. You come up with document. I move now to requirement specifications. Requirement specification. Requirements specification, this means what am I required to have. So this one will entail so much. We have the output specification. So the equipment that you require now. One is the output specification. What kind of output do I require? Do I require it in soft copy, in hard copy? And this is where now I determine the type of output that I'm going to use. So if I require a monitor, what size, inches, and so on and so forth. We have the input specifications. I said about the inputs, this is what you key in a computer for you to get the information. And therefore, the inputs, what kind of input do I require? Do I require to scan? Do I require to key in? So you have to come up with the type of input specification that I require. So if, for example, I want to type, then a keyboard is required. If I need to scan, you will need, for example, a barcode scanner. You require a barcode scanner. And still, what you want to scan, for example, if it is books in the library, then it means you require barcodes. You require barcodes. We have file, so data structure. What type of file? What type of file do I want to save? What size? Therefore, you have to consider even the hardware in the file. You have to consider. Then you have the hardware and software requirements. See that the requirement specification. Hardware. So hardware mostly here you have to know what size. If it is memory, for example, the size of the memory, what size of the memory do I require? Therefore, you have to know the type of information that you want to key in, what kind of hardware do I require, the type of components of the computer. Do I require a keyboard? In the hardware, for example, I say you want to use a scanner, so you need to purchase a barcode scanner. So that will be hardware. We have the software requirements. Remember, we looked in from one, we looked at types of software, and software, it can be a system or an application software. So you find that at times these softwares are not compatible with each other, and therefore you must be in a position to know this software is compatible with this one. For example, if it is the operating system, is it compatible with the application software that I want to use? Now, having done that, you will move to the other one, that is system design. We want to design a system, and this one, when you are designing a system, you will understand that this is not actually creating the system. You have not started creating the system, you are just designing. I can give an example with a constructor. Somebody want to build a big house. You don't just wake up and go start building. You will start by drawing a design. So actually this person will be using will be designing the system. And when you're designing a system, there are things that you use. We look at them in the programming, and one of it is a flowchart. Here you have to use the flowcharts and the pseudo codes. So those are some of the things that we use. The system flowcharts. So in design stage, the analyst must come up with ways of solving a problem. So you want to come up with the ways of solving a problem, not actually creating the system. So here you can use the flowcharts, which we covered in our last topic, that is the programming. You can use entity relationship models. We have the structure charts, but mostly use the flowcharts and the pseudocode. And last but not least, you have the data flow diagrams. So having designed that, you will be in a position to know, is the new system going to work? So that's the essence of designing. That's why then the builder or the constructors will start by designing, because they want to know, will it work? They even tell you how much do I require. If it is I want to build a stone house, they will tell you the cement you require this one. Still, even the design, this one now you'll be able to tell I require this amount, even talking of money and so on and so forth. After the design now, after completing the design, you move direct to coding or system construction. Now coding, this is now the actual creating of the system. You are now creating the system using a particular programming language for that matter. So you move to the system construction. And this one, so it refers to coding or installation and testing of the modules and other components. When I talk of modules, you know, these are sub-programs or subsystems. So it's a small program we call a subsystem or the modules. So that is it, system construction. You have to use the coding, use the programming language that you think it is the best for you, and still the one that you have knowledge about. And if you are creating a system, you are in a position to tell which is the best programming language to use for you to come up with the best system in terms of reliability, security, because you might use a certain programming language and then you find that the security of your data is not there. After the coding, you move to testing and implementing. That one you understand what it means. Now I have created the system. Is it going to work? Is it going to work? So the system has to be tested. In testing and implementation, you find that mostly we use the test data. Test data. When I talk of test data, this is where you key in data that is like the one that is going to be used. So you are just testing. So for example, I created a program to calculate the area of a circle, and it was meant to calculate for a very large area. I can start trying with a very small number like 7, the one that I can then do with a calculator and see the program is giving us the correct result. So that is test data. Use data to test. Even in school, I give another example of testing. For example, we have so many programs like the one that produces results. You find that system, that person who created the system, before you install it there, you have to test. And by testing, you even put values that you know that they are wrong. For example, you know a student cannot score over 100. Therefore, you should try that system. Key in 200. And then it should tell you that is an invalid result. If it puts the result, then that program has a challenge. And you can even put a negative. For example, a student cannot score a negative. So it will be able to tell you if it accepts, then there's a challenge or there's a problem with the system. And then last but not least, we have system review and maintenance. System review and maintenance. So now the system has been tested. It has undergone all those stages. All of them have been completed successfully. And that's now the time. Now the system, you review the system. It has already now been installed, and now you have it. Maintenance, we have to keep maintaining the systems. You know, at times they have challenges. Or for example, you have students, for example, come here in school. You find that Form 1s join us every year. Form 4 are leaving. Therefore, when you include new members in the system, it means it is part of maintenance. And then you can release those who have left. Now you have looked at the system development. For your assignment, you look at changeover strategies. Strategies that are used for you to come up with a new system. Thank you for listening.